Hello class, Mr. Parsons here. I just want to take a few minutes to talk to you about comparing functions. Alright, so we've been talking about functions or whatnot throughout this particular unit. We want to compare the different types of functions in different ways. So you look at a function that's an equation, you can look at a function that's a graph, you can look at a function as a table, as an equation, as a graph. Alright, and so let's take a look here. We want to determine the rate of change in the y-intercept of the functions below. G of x is a graph, and f of x is a table. Define your rate of change, which is your slope, from a graph. One of the ways you can do it is rise over run. Select 2 points on your graph, and then do your rise, your vertical distance over your horizontal distance. My rise is 8, my run is 4. So if we do rise over run, or my vertical divided by my horizontal distance, we get 2. So our rate of change is 2. If you look at the table here, if we find our rate of change, one of the ways you can determine your rate of change is doing the slope formula. That's y2 minus y1 divided by x2 minus x1. So we make this f of x and y is the same thing. So we can make this y1, y2, x1, x2, and we can say, hey, let me backtrack, sorry. Your y-intercept on your graph is where it crosses your y-axis. It crosses my y-axis here at 8, so 8 will be your y-intercept graphically. My apologies. Now I can go to the table. And so utilizing our slope formula, we do the y2 minus y1 divided by the x2 minus x1. If we do 7 minus 1 over 0 minus negative 2, 7 minus 1 gives you 6, 0 minus negative 2 is 2. And 6 divided by 2 gives you 3. So the rate of change, which is your slope, of the table is 3. All right. And then your y-intercept. All you got to do on your table to find your y-intercept, see what x is 0, find the corresponding y or f of x, your corresponding output. That's going to be your y-intercept. So if you look here, all right, we have when x is 0, my output is 7, so my y-intercept will be 7. All right. So 7 will be the y-intercept there. Now, let's compare. All right, g of x has a higher y-intercept than f of x, but then f of x have a higher rate of change than g of x. And so if we was to go here, another way you can find out what your equation is, or your rate of change and your y-intercept from your table, if you use your Desmos calculator, type in these values in the table, and then do the click on the create regression. When you create the regression, and then it creates this equation. Notice y equals 3x plus 7, where 3 is the rate of change and 7 is the y-intercept. All right. Now that we made our comparisons between the two functions, look at this question here. What can we conclude about g of x and f of x? We already said that g of x has a higher y-intercept than f of x, and then f of x have a higher rate of change than g of x. And so if we go to this question, what we can conclude, our answer will be C. The function g of x has a greater y-intercept than f of x. All right, let's take a look at this here. We're looking at plane 1, which is as a graph. Plane 2 is an equation. Think about your slope-intercept form. Y equals mx plus b, or instead of y, you might see f of x. F of x and y is the same thing. They're both outputs. All right. So if we look, it says which plane has the greatest rate of change. Rate of change is the same thing as saying slope. So if I look at my graph, what I can do is I can do my rise over my run for plane 1. All right. So I choose 2 points, and then I do my vertical distance over my horizontal distance. All right. Look at the intervals. They count by 5,000s. All right. But then look here. It stopped between 5,500 and 6,000. So it's halfway. So half of 5 is 2.5, or half of 500 will be 250. All right. So we don't know for sure, but we can guess because it's half. And so we can say that our vertical distance is 2,750, and our horizontal distance is going to be 11. So we do our rise over our run. That's going to give us 250. So 250 will be the rate of change of plane 1. So it descends at a rate of 250 meters per minute. If you look at plane 2, This is in your slope-intercept form, which is y equals mx plus b. M represents your rate of change. 200 is in place of m. All right, so 200 will be your rate of change. Now, look at your y-intercept. All right, if you look at your graph, so let's go to the first question. Which has the greatest rate of change? All right, plane 2 has a rate of change of 200. Plane 1 has a rate of change of 250. So we could say plane 1 has a greater rate of change of 250 versus plane 2. All right, now let's look at the greatest altitude. Here we're talking about the y-intercept. All right, look at graph 1 or plane 1. It crosses the y-axis here. So between 5,500 and 6,000, we can say this. If it's halfway, we could say maybe what 57,050. All right, and then if you look at plane 2, look at your y-intercept here. It's at 1,200. And so your y-intercept in context of a real-world problem, that's when you start your initial value where you start. So in this particular instance, the plane was already at a height of 5,755 meters in the air versus plane 2 is at 1,200 meters in the air. So which plane has the greatest altitude? That will be plane 1. All right. Let's take a look here. We got function A, which is a table, versus function B, which is a graph. Which function has the greatest rate of change? So again, with your table, you can do your slope formula, your y2 minus y1 over x2 minus x1. All right. And then function B, you could do your rise over your rank. So let's look at function A. All right. We want to do, this is x1, x2, y1, y2. So we're going to do, excuse me, I did it the other way around. This is x1, x2, y1, y2. So we did 12 minus 0 over, I did this incorrectly. I supposed to did 0 minus 12 over -4 minus -1. I did it the wrong way around, and I know that because, yeah. Okay, let's take a look here. It's supposed to be 0 minus 12, not 12 minus 0. So it's going to give you 12. It's supposed to be -12 over 3. And so that's supposed to be -4, not 4. All right, -4 should be the rate of change here because it's decreasing as x increases, my y decreases. So this is supposed to be -4. Let's look at function B. All right, function B, if we look at our rate of change, we want to go ahead and do our rise over our run. Oh, and also the greatest altitude, look at your y-intercept. So my y-intercept is whenever, that's incorrect as well because the y-intercept is when x is 0, look at the corresponding y. This is the x-intercept. So let's go back and fix this. I apologize. All right, this is the x-intercept. This is not the y-intercept. So the slope or the rate of change is -4. We already know that, right? So if at 0, I'm at, well, when x is at -1, I'm at 0, right? So when I go to increase to 0, because as x increases, y decreases, right? So if I go to 0, then this would go from 0 to -4 because it decreases by -4 each time. So -4 looks like it would be the y-intercept and not -1. So -4 would be that because it decreases by 4. My apologies. I'm not sure what I did with this problem here. Look at function B. All right. So this should be actually f of x equals -4x minus 4, not -1. All right. Look at function B. All right. If I look at function B, I choose my 2 points. I do my rise over my run. All right. So this is 4 over 2. 4 over 2 gives me a rate of change of 2. And then look at where I cross my y-axis. I cross here. So 1 will be my y-intercept. So my y-intercept will be 1. So it will be f of x equals 2x plus 1. which function has a greater rate of change. Even though this is a -4, 4 is faster, so it decreases faster than function B increase. So function A still has the greater rate of change. As far as the greater altitude, that's going to be, well, it's still going to be function B. Function B going to be an altitude of 1 versus function A will have an altitude of -4. All right, let's look at this one here. Which function below represents the salary preferred? Look at salary A, base salary of $250. So that's how much you get paid no matter what, plus 15% of the merchandise you sell. So think about that as an equation. All right, 15%, which is 15x plus 250. All right, and then look at function B. If we find our rate of change in our slope, all right, look at our rate of change, our rise over our run. So 100 over 500, which gives you 0.2. So that's 0.20x, and then look at where your y-intercept is at 200. So 0.2x plus 200. So let's compare. Notice, function A has a greater y-intercept, meaning the greater initial value. But function B has the greater percentage. So if I look at this, if I put both of these equations in my Desmos, right, this is what it looks like. So initially, function A, you'll get more money, all right, initially. And then until you get to a certain point, all right, so after you have about, as far as the price of merchandise, right, after you make about $1,000, right, then it's going to be the same. At that point, function B, you're going to start making more money than function A. So in the short term initially, function A, you'll make more money, but in the long run, function B is going to be what you want to choose. All right, and then let's look at this one. And so what we want to do is, we're looking at a smartphone and want to make the most money and sell the most phone possible. All right, and the company wants to price the phones appropriately. So look at the supply. Look at this function, 0.4x plus 200, and then look at the table. How does the rate of change for the supply, which is here, compare to the rate of change here? So let's take a look. So look at the rate of change. You know that since it's an equation, y equals mx plus b, right? M represents your rate of change. So here, 0.4 is your rate of change for the supply function. For the demand function, what we can do is we go ahead and do our y2 minus y1 over our x2 minus x1. So 370 minus 490 over 300 minus 100. And that's going to give you negative 120 over 200, which is negative 0.6. All right, so negative 0.6 is going to be our rate of change here. All right, and so it says, how does the rate of change for the supply function compare to the rate of change of the demand function? Even though it's negative, you're looking at how fast. So 0.6, look at the absolute value. 0.6 is bigger than 0.4. So technically the demand will have a greater rate of change than the rate of change of the supply. So I also did that incorrectly because the rate of change for the, that's what I did. The rate of change for the demand is higher because it decreases faster than this increases. All right. And now let's look at this last one right here. One in Patty could read books a month. Patty already read 5 books. So the graph shows Patty over the next 10 days. What is the rate? So let's take a look. Let's do our rise of our run. So that's going to be 7.5 over 6. 7.5 over 6 gives you 1.25. So Patty is reading 1.25 books per day. If Juan read no books, meaning your y-intercept is 0, all right, and he read the same amount rate as Patty, which is 1.25, how many books would he read by day 12? So 1.25x would be your equation. Substitute that for 12, and then you're going to get 15. So Juan would have read 15 books in 12 days. And so what we're doing, we're comparing functions. We're using the different type ways of our functions, and we're comparing our rate of change and our y-intercept between the various functions. So I hope this helps with comparing functions.